recording going to the cloud. We get rid of this stuff. So number 26 and 27, numbers 26 and 27, both have equations given to you to some extent. So they're a little bit easier to handle than the other word problems that we did, because some folks find, and I think I agree with this, that the most challenging part of word problems is coming up with the equations themselves. But without further ado, the relationship between intensity I of light in lumens at a depth of x feet in Lake Erie is given by this log equation. What is the intensity to the nearest tenth at a depth of 40 feet? All right. So they're basically telling us to find I when x is equal to 40. All right. So I have my log equation. Log without a base indicated, that must be a base 10 then, of I over 12 is equal to negative 0.00, double vision here, hold on, 235 times the value of x, which is given as 40. So I want to release the I from logarithmic captivity. I'm going to take that 10 and raise it to the power of negative 0.00235 times 40. And that'll be equal to I over 12. Then if I want to get the I alone, all I'd have to do is multiply both sides by 12. So what I'm going to do, cancel, and pop all this into Desmos. 12 multiplied by 10 raised to the negative 0.00235 times 40. Oh. Put the exponent in parentheses so that it keeps it as part of the exponent. And so they said to the nearest tenth, so the whole decimal is this, but this would round to about 9.7 lumens. All right. So that's it for that one. Much, much simpler because you didn't have to invent the equation on your own. All right. I'm just going to take a second here and show you how to do this on the TI. There weren't so many instances throughout the course where you would have really needed to go back and forth between Desmos and the TI calculator. It's just we're getting to the part of the course where Desmos does a whole lot more than the TI calculator would do. And based on where you end up next semester, I don't want to put you in a position where you know how to do all these things on Desmos and know how to do absolutely nothing on the TI. So let me open my TI calculator. This one is just straight number crunching. So it's really not that bad. It's 12 multiplied by 10. When you want to raise to a power using the TI calculator, remember it's that caret symbol. And with the TI-84s, it actually makes it an exponent. All right, but the thing you got to be careful about with the TI-84s is that there's a different button for a negative than for a minus. So here I want negative 0.00235 multiplied by 40, and it'll spit that value out for you. All right. But what I wanted to do, aside from just that little bit, is show you how you could solve something like this using some of the other features that are built into the TI calculator. One of which is the intersection function. But there's actually something even better. Now, this is an emulator, so there's a chance that it doesn't look exactly the same, but let me see. Okay, yeah, it's fairly similar. There's a function called the solver. Now, the solver on the TI calculator is actually an equation solver, but it kind of works in a weird sort of way. So let me show you how you would handle something or solving an equation using the TI solver. Now, again, not necessary for everyone, because if this is the last math class you've ever taken, what I'm about to show you may be irrelevant. But if you're going to find yourself in a calculus class next semester, I don't want to make it as dramatic as it's going to seem. You're going to need all the help you can get. It's not really that bad, but it's more like if there's a resource out there that you can use, why not learn about it now? Right. So I have my equation here, and I'm just going to rewrite it. All right. I'm going to get rid of all this fluff here. So on the TI calculator, there's a function called solver. All right. So using solver. All right. It's in the math menu. If you scroll down, you see one that says solver, but it might also say numeric solver. Depending on the model calculator you have, it'll look different, right? In some cases, it's actually very self-explanatory. And in other cases, it looks like this. So,
Professor, isn't there a log button? Yeah, there is a log button.
Yes.
Yeah, okay.
So one of the displays for solver is, and there's also a function called log base. I'll show you that in a minute. That allows you to put in whatever base log you want. So what we're going to do is use this setup here. It says EQN, and then it has the 0 built in. All right. So what we do is we take this equation and we solve it so that there's 0 on one side. All right. So get everything over to one side. All right. And in a lot of cases, that's just a matter of subtracting from one side to the other and maybe, performing a negation. But in this case, we're looking at log base 10 of I over 12 plus 0.00235 times 40 is equal to 0. All right.
Professor, when we did it before you started doing this particular method, how did you get 9.7 lumens? Like, I'm a little confused about that. Like raising 10 to the negative 235 to, like, do you multiply the negative to 40 and then raise, so you multiply negative 0.00235 to 40, then you raise 10 to that power?
Yep.
And then you times it by 12 and somehow you got 9.7?
Yep.
How did that happen? I didn't get that. Okay. All right. Thank you.
Yeah, no problem. It's math magic. Yeah, it's because you're taking the 10 and raising it to a really small power. So then when you multiply, when you take that 10 and raise it to a really small power, you're getting a number less than 10. When you multiply that by the 12, it brings it down to a 9 and change. But it does sometimes feel like a little bit in the realm of black magic. All right, so in the equation solver, you would type in this expression, the left-hand side. So I'm just kind of backfilling it in over here. That's not a rectangle, but I'm going to live with it, right? So now a log base 10 is the same as saying log. So I could just type in log. I over 12, and I'm going to use x. Use whatever variable you want, as long as you're consistent. So then you get all this stuff in there. Oh, that happened way too quickly. I didn't want that to happen right away. I wanted it to be like an impressive reveal. All right, well, pretend that x equals stuff isn't there just yet. All right, pretend it looked exactly like it did a second ago. All right, what you would then do is hit enter, and then it'll bring up an x equals, but that x equals is not, it's not the right answer. All right. So what you would do is hit enter, then clear out what's in there, and then hit alpha, enter. All right. Or you could just leave the number in there and hit alpha, enter, and it'll solve it for you. All right. Because it'll overwrite it. You clear it out, put a 0 in its place, you know, just to not be distracted by that funky decimal that was there. But if you then hit enter so that you get to the x equals, and then hit alpha followed by enter. On your calculator, if you have a TI-84, right above enter, you'll see it's written there. It's not written on mine because it's an emulator, but it says solve, which is what you would get if you hit alpha enter. Right? And so that'll actually solve the equation for the variable x. Right? The issue with this technique, and the reason why we haven't used this technique before, is because it's not as cut and dried if there's more than one solution. It's doable, but there are many more steps involved. Right? But if there's only one solution to an equation, then it's a wonderful approach. All right. So, like for example, I'll do something very simple. Let's say I have like x plus 2 equals 0. All right. So I hit enter on it to get me down into this x equals business, and then I just hit alpha enter, and it'll solve it for me. But it's only solving because there's exactly one solution to this equation. Right? If there's more than one solution, it'll still solve it. It just might give you the value of x that you're not interested in. I could show you a really quick example of that. X squared minus 4. Let me do something else. X squared minus 20. Okay. X squared minus 25. I must have hit clear along the way. All right. If I hit alpha enter, what it's going to do is it's going to take me to the solution that's closest to the number that I have on the screen. That'll take me to a -5. So if I put in a 10 here, for example, and then I hit alpha enter, it'll take me to the solution to this equation that's closest to the number that I had typed in there initially. Now, so that's really good if you have a sense of the answer, but you don't know exactly what the answer is, which is why I like it for a log problem. Because if I look at the graph of this, you know, let's say I'm just looking at the graph of the left-hand side, log of x over 12. And I want to see where that's equal to, let me just do this in the home screen, -0.00235 times 40. So I want to see where it's equal to about -0.094. All right, so that's lovely. But I can look at the graph. I got a hell of a zoom here, so let me get a better window here. -10 to 10. All right, so I'd be looking at where this graph is equal to 0. which is going to be right or close to negative 0.094, right? Based off of this calculation. So I would have to figure out just about where this graph hits 0. So it would be somewhere in the neighborhood of 12. Right. So that would give me a good starting point. So if I were going to estimate, and I have some decimal values that I could work with here, 0.094, I'm looking at something in the neighborhood of 9 to 10. So if I had to estimate, I'm going to guess somewhere between 9 to 10. But at least with the solver, that gives me a good place to start if there's more than one solution. But with the log equation, if it's going to intersect with a horizontal line, it's only going to intersect at most once. All right. So it's kind of nice in that regard. Now, as far as that, because I'd be neglecting my own personal desires when it comes to technology here if I didn't show you the Desmos solution. Right, so log x over 12. Oops. And then, so the left-hand side goes in as one equation, the right-hand side goes in as another. All right, both of them should be equal to y, so y equals, and we look for where they cross. All right, so they cross right here at a y value of, I'm sorry, next value of 9.665, which rounds to 9.7. All right, so easy enough to do by hand, but there's also some other checking mechanisms that come into play. And you'll see that even with more complicated equations, this process will bear out. And this is one reason I was showing you both the Desmos and the TI approach for this, is because when we get into the trig stuff, there will be many instances where you look at it and say, I don't know the answer. Maybe I can figure it out on the calculator. Or if you have a kind of similar mindset to me, it's like, I know I can figure out the answer. It's just going to take about 15 minutes, or I can take 15 seconds and do it on the calculator. Right, that's probably more along the lines. All right, so Tiki went to a rock concert where the decibel level was 88. Decibel is defined by the formula you see there, where D is the decibel level of sound, I is the intensity of the sound, and I sub 0 is 10 to the negative 12 watt per hour, geez, saying it like electricity, kilowatt hours, watt per square meter, and that's a standardized sound level. It's the threshold of human hearing. So they basically told us to put in a 10 to the negative 12 for the I sub O. All right, use this information to find the intensity of the sound at the concert. All right, D is the decibel level, so that's 88. So we have an equation here, and we can solve it a couple of different ways. I can divide both sides by 10. So 8.8 would be equal to log of I over 10 to the negative 12. Remembering that when I see a log without a base indicated, it's implied to be a base 10 logarithm. So chuck a little 10 in there. All right. I want to convert this over into exponential form so I can release the I from captivity. Log jail. So 10 raised to the 8th, 8.8, that's a way of saying it, would be equal to I over 10 to the negative 12. So I would have, again, 10 to the 8.8 is equal to I over 10 to the negative 12. All right. If I multiply both sides, right, well, I can do this a couple of ways. I can multiply both sides by 10 to the negative 12. or I can rewrite this as I multiplied by 10 to the positive 12. You know, just moving this up to the top is property of exponents. If you move from one part of the fraction to the other, so bottom to top or top to the bottom, you can do that as long as you negate the exponent. All right. So then on the left side, I have 10 to the 8.8, but then you'd see here, I'd have to divide both sides by 10 to the 12th power anyway, which would have been the same as multiplying both sides by 10 to the negative 12. All right. So you got a few different pathways that you can take to get your solution, but it's really up to you which way you want to go. All right. Now you can keep the base and subtract the exponents if you want, or you could just kind of chuck it right in. 10 raised to the 8.8 over 10 raised to the 12th. And you get this funky looking decimal, but that's okay. All right, we could write it like that, or we could write it as 10 to the negative 3.2 power. That's possible also. All right, but I mean, this is fine. So 0.000631. 0.00631. All right. So there we go. Now let's see. This is watts per square meter. Oh. I'm going to write it like this, like so it looks a little cleaner with the units. All right, and that comes from the units of the I sub 0, which is the same variable, just a different measure. And that's measured in watts per square meter. So we would just steal those units and just use that for our answer. Right. Now, if we wanted to do this, so we'll do it two more ways. So one way would be with the Desmos. So y would be equal to 88. So we just remember, when you're solving with Desmos, if you're solving an equation, you take the left side and the right side, and you put it in as two separate equations. And then you just see where they cross. So y equals 88, enter. Y equals 10. It's a common log, so I just type in log, L-O-G. I'm going to use x instead of I. 10 raised to the negative 12th power. All right. So I have my home zoom on here, and it's not showing anything. But I also notice that my y value, my y equals 88, that's definitely bigger than 10. So I'll hit my little wrench here and make my y-axis go up to like 100. All right, so now I got my y equals. I also need to see the actual log equation, which doesn't seem to be showing up. So I can pinch zoom out from there. And now I could actually see the curve. It looks like the curve is going to intersect somewhere over here, right? Because it looks like it's increasing without bound as I go to the right, right? So it's going to be somewhere very close to the y-axis. So instead of going out to like 20 in terms of x, I'll start off by going out to like a 1. I'll go from 0 to 1 and see what's happening there. It's still even a whole lot closer than that. So how about 0 to 0.1? Right, I can almost see that intersection. If I zoom in more, I can see it. Tap, tap again, and we get our 0.00631. All right, so you got to kind of wrestle around with it a little bit. Good looking graphs, I'm going to keep it. But you'll get there. It's just a matter of being a little patient with it. All right. But now let's go with the solver approach on the TI. Copy. Delete the screenshot. Just going to chuck that right in there. Make it super tiny. All right, so now the TI, using the solver method. All right, so for the solver, again, we want to get everything over to the same side. So in the solver, we would write in 0 equals 88 minus the right-hand side. That would get everything over to the same side. So 88 minus 10 log, all that stuff. So 88 minus 10 log I over 10 to the negative 12th power. All right. So math, go to solver, put in your equation. Again, 88 minus 10 log. We're going to use x divided by 10 raised to the negative 12th. And then alpha enter on the x equals, because the answer is certainly not 5. But if I hit alpha enter, it'll solve that equation for me, 0.000631. All right. So we got 3 different ways to come up with the same answer. And you're like, well, I'm not going to do it all 3 of those different ways. Do it the one way by hand, know how to do it that way, and then have at least one of the technological approaches to back you up. All right. That's really the key to everything. All right. Now, number 29, Bank A pays 8.5 interest or percent interest compounded annually. All right. So compounded annually is one formula. So that's A equals P times 1 plus R over N to the NT power. All right, so that's bank A. 8.5%, so R is equal to 0.085. Annually, the N is going to be equal to 1. Right, because annually happens one time a year. Bank B is compounded quarterly. Right, same formula. The interest rate is 8%. Both of these interest rates are pretty obscenely high. They were shockingly the norm. Well, no, they were the high end, but they were still possible back when I first made this word problem. Interest rates were about like 5.5% on average. But if you wanted to like do a little bit of a high risk, or well, more high risk investment, then you could get up to 8 to 10%. Then you started getting into like Bernie Madoff Ponzi scheme sort of territory. But regardless, it was possible. So interest rate here, 0.08, the end value quarterly happens 4 times a year, right? Once every 3 months. If you invest $500 over a period of 5 years, so in both cases, the principal balance would be $500, and the amount of time would be 5 years. Poor quality 5, let me fix that. What's the difference in the amount of interest paid by the 2 companies, or by the 2 banks, sorry. So this is just pure plug and chug, which isn't bad. So A, in this case, would be 500 times 1 plus 0.085 over 1 raised to the 1 times 5 power. Whereas this one would be 500 times 1 plus 0.08 over 4 raised to the 4 times 5 power. All right. In both cases, it's compounded on a periodic interval. But one case you get a little bit more interest, but it gets compounded less frequently. The other case, a little less interest rate, but compounded more frequently. So you want to see how that plays out. All right. So we can crunch these numbers. We can do it a bunch of different ways. We can use technology. I mean, to some extent, you're using technology one way or another, but it's just a question of how much you want to use the available resources in something like Desmos. So 500 times 1 plus 0.085 raised to the 1 times 5 or 5 power. So we're talking about $751.83. All right. And then for the other one, oops, over 4 raised to the 4 times 5 power. So 742.97. The difference of approximately, so 742.97, oops, come on, 97 minus 751.83, difference of about $8.86. All right. Now that may seem insignificant, but that's a difference of $8.86 for nothing, for doing nothing. All right. You would not have done anything to earn or lose that money. All right? It's just a choice in different types of accounts. All right. Also, bearing in mind that this is $500 invested one time in the beginning of a 5-year period, and it's allowed to mature over a period of 5 years. If you think about taking $500 and investing it, for example, once a month for a period of 5 years, then that $8.86 definitely becomes more substantial. All right. So, you never lose the respect for the compounding concept. Right. And especially when you start to have to repay loans. For those of you, if you're already paying some kind of loan, you know what I'm talking about. But there's also the idea of paying a mortgage. And you can you see it when you see the repayment schedule. It's really kind of heartbreaking, because you don't always realize just how much you're paying in interest until you see it broken down. And when you realize that the first at least half of the repayment period of the life of the loan is you just paying off the interest before you start paying down the capital or the principal balance, that's pretty nuts. And it's really kind of crazy. Like you'll see it. Like if you're paying a mortgage, you know exactly what I'm talking about. But if you're living at home and your parents are maybe paying a mortgage, ask them to take a look at the bill, just so you can see, from month to month, you'll see the repayment, but then you don't see the principal balance going down, at least early on. It'll be like, all right, let's say you have a $400,000 mortgage. After you pay for like a year, you'll still see like the principal balance of $400,000. It'd be like, how much do you still owe on the mortgage? You still owe what you owe, but how much do you owe against the initial borrowing amount? It'll say something like $399,000. You're like, but I paid for like a couple of years. How is this possible? Because you're still paying towards interest. Okay, a good rule of thumb, and because interest rates are what they are now, this rule of thumb applies. But if it changes, then the rule changes with it. But take whatever you want to borrow and double it, and that's pretty much what you'll have to pay back throughout the life of the loan. It varies based off of that, but that's pretty insane when you think of it that way. So case in point, still paying off my student loans. I've been out of college since the year 2001. Right, that's when I graduated NYU grad school. Undergrad I finished in 2000, grad school 2001. 20 years later, I'm still paying it off, and that's at the prices of 20 years ago. I can only imagine for private university what it would cost now. My understanding is my entire loan balance is what it costs for 1 year now. Right? So I mean, it got me to the point where I'm seriously questioning whether it's absolutely necessary for my son to go to college. It's like,
Is it worth it? That's the thing.
because it is the thing. It's a hell of a question, because now you got to do the analysis and say, all right, the job that I'm trying to get, is it worth it? Let's just assume I make the most amount of money that the job that I'm trying to get will pay. Reduce that bi-weekly paycheck by the cost of the student loan. Is that going to be more money? What's left over, will that be more money than I would earn doing, and that, pick another field that doesn't involve having to go to college and pay out a ton of money?
All my friends we're in our late 30s. All my friends are still paying off their loans as well. They make more money than I initially started making as like a construction worker, but I have no debt. So I don't owe anything. So I never really ask, because you don't talk about money. It's kind of awkward.
Right.
But so you make X amount of money and I make X amount of money. But to me, it seems like we're kind of making the same amount of money, if not less, on their behalf. So is the degree really worth it as we sit in a college course?
Yeah, it's a hell of a question, but at least the one thing I could say is you're sitting in the right college course, in the sense that tuition at a community college rate is not as bad as it could be.
We're
It's
all
still,
sitting in the right college. This is the correct college.
Yes.
This isn't the party school. This isn't the Ivy League school. No offense, but this
Right.
isn't some private institution. This is a community college, and you could afford it, and you can still get a good degree.
You still get a good degree. It's let's get down to business. Let's get to work. We're trying to get on our career paths here, and it is the step in the direction to take you to the place that eventually you would want to go. And usually that ends up being a good place, but it all depends on how much work you put in, obviously. But I mean, it's a travesty how much the 4-year stuff costs. And I feel for anybody going through that system now, as I'm sure you're all going to be feeling for me. My son's 11, so I got a few more years, but when I gotta pony up the dough for that bill, that's going to be something. I don't know.
You could teach Math 135 to help pay for the bill.
Yeah, I know. That's the thing, that it wasn't available.
Oh, wait, really?
Yeah, that's the thing.
Don't you have like 20 years experience?
Yeah.
Like with the college? So who the hell is above you?
There are all the full-time faculty are above me. So a full-time faculty member with like 2 months of experience is above a senior adjunct with 20 years of experience. So there's that. And then there are, believe it or not, there are some senior adjuncts that are more senior than me. I believe it's either 8 or 10, it's somewhere between 8 and 10 of people that are still ahead of me in the pecking order. But I tried.
I'm so upset. I never get to take the same professor, and math really requires you to have some sort of consistency. Like, you kind of threw me for a loop with the Desmos thing. I was like, oh God, please. But it's actually a lot easier.
Yeah.
So if you use that for the next class, it would be nice, but somebody else is gonna screw me over with some other program that's not my math lab, Desmos, or some third thing I took. Oh.
Well,
Did
the one thing I can say is we're running out of different forms of technology to screw you over with. So, so, so odds are we're probably at the limit of it. So there's bound to be a repeat here.
Thank you.
No problem.
Are there,
right.
is this gonna be on the test, by the way, this word problem stuff?
Oh yeah,
Oh, Christ.
but only one problem.
Okay, thanks.
All right, so number 30, this is the last one in the exponential log portion of the unit. Determine how much time to the nearest year is required for an investment to double in value if interest is earned at a rate of 5.75% compounded quarterly. I guess I didn't count. Right, so compounded quarterly, so back to this formula. The idea is that we want to double our initial investment, all right? So if we're doubling it at a rate, so our value is going to be 0.0575. It's compounded quarterly. So n is equal to 4. Quarterly happens 4 times a year. We just want to know how long is it going to take for whatever this number is here to become double that. Right? So you can put in whatever you want for P, as long as A is double that value. Right. So what I tend to do is put in a 2 and a 1, because no matter what I put in, it's always going to simplify down to those two numbers anyway. So I could have put 100 here and 200 here. First thing I would do is divide by 100, divide by 100, it'd become 1 and 2. So it's like, why not just cut to the chase and just put the 1 and 2 in there initially? Right. You put in 25 and 50, you put in 1,000 and 2,000. Right. So we're solving for T here. So it's another one of those situations where decide which method you want to use. You want to go Desmos, you want to use a by hand approach, whatever it takes. So I'm gonna, well, you already know. I'm gonna do it all the ways. So 1 plus 0.0575 divided by 4. So that's that decimal. So I'm going to rewrite this as 1.014375 raised to the 4t is equal to 2. All right. And I'm writing it like that, so I'll have it in that tailor-made form, ready to rock and roll for a logarithm. All right. So log base 1.014375 of 2 is equal to 4t. All right. So then we could do a quick double check and just make sure that doing that little circular motion thing would get us back to the exponential form. And if it does, we know we're in good shape. And it does, so we're in good shape. So if I want to get the t alone, I would divide both sides by 4. I'm going to rewrite just because it was getting a little cluttered. Log base 1.014375 of 2 is equal to 4t. I'm going to divide both sides by 4. And then just pop it into Desmos. All right, so a little fraction, function, miscellaneous. So again, miscellaneous, to bring up the log with that little subscript, type in 1.014375 of 2. Close it up, put a 4 on the bottom. and we get 12.1. Let's see, anything for rounding to the nearest year. So about 12 years. All right. So at this interest rate, it would take 12 years to double your money. And that's interesting because that means no matter how much money you're starting with, after 12 years, you will have doubled it. So if you start off with $1, after 12 years, it'll become $2. But if you start off with 10 million, after 12 years, it'll be 20 million. All right. So it's not a proportional relationship, it's an exponential relationship. The more money you put in, the more money you get out. But over the same period of time, which is really interesting. Now, if you want to do the whole shebang on Desmos, we take the left side of the equation in whatever form. I mean, if you want to do some simplifying first before putting it into Desmos, that's fine. But any form of the equation can be put into Desmos, even its most hideous. All right, so y equals 2. Y equals 1 parenthesis. You really don't need the 1, but I'll put it in anyway. I want to keep it nice and hideous. All right, so we have left side in as one equation, right side in as another. We have the two curves look like they're bound to intersect at some point. If I scroll a little bit further, I see that they're going to intersect right here at 12.141. Wonderful. Nice and easy. On the TI, we'd use the equation solver. So on the TI solver, we would type in 0 equals 2 minus 1 parentheses 1 plus all that stuff. But we'll use an X just because that's how the solver understands it. But again, when you're using the solver here and it says equation 0 equals, if you want to get this whole equation in here, you got to get everything over to the same side, right? Now, there are newer operating systems for the TI calculators that when you hit solver, so if you don't have a TI calculator and you go out and get one and you hit the solver, you might actually see a much nicer interface. There are the newer software asks you to put the left side in and separately the right side in of your equation. So it's even easier, but I think that kind of doesn't really need as much explanation. It's just this format that needs the most explanation. So I pop it in, I hit down or enter, and then alpha, enter, and it'll solve for me. And so alpha, enter. It says X is equal to 12.14117086794, which is the calculator's way of telling us. Oh, that was looking pretty good too. I don't know why I changed it. Calculator's way of telling us about 12 years. So I'll stop.